And here we are already at the very end of Module 7, where we're going to start Lesson 4, which is multiple representations. The goal is that students will use tables, equations, and graphs to represent their relationships, which I think we've kind of been doing all of that. And the suggested pacing guide says this is going to be a quick and skinny lesson. Hopefully we will maybe be able to knock it out with one video. I don't know. We're just going to have to see how it goes. Have you ever watched a race like a marathon? Honestly, why would you want to stand there and watch other people run? I mean, really, what thrill do you get out of watching other people run? I don't get it. But a marathon itself is 26.2 miles. A little history there. Legend has it that marathon began back in the Greek times when somebody was a group of soldiers were being attacked, and they had somebody run to or from the city of Marathon to let them know that, hey, we're being attacked. He ran up to where the king was located. He told them that, hey, we're being attacked, and then he fell over dead. True story, or at least as far as the legend goes. The distance he ran was 26.2 miles, roughly, and that is where the marathon had its birthplace. So if you want to run 26.2 miles and then fall over dead, you too can have a marathon. Lest I have digressed, though, one of the fastest marathons completed by an African male was done in 2 hours, 4 minutes, 58 seconds. He ran 26 miles in just over 2 hours. That's an average speed of like 13 miles per hour running. Most people cannot bicycle that fast for 2 hours. Says this is an average speed of 12.58 miles per hour. In comparison, the average marathon speed is about 6.2 miles per hour, so he was about double the average marathon speed. And this would take about 4 hours, 13 minutes, and 23 seconds. More than double the fastest time. Runners might use equations or graphs to help them determine how fast they need to run or predict how long it's going to take them to finish a race. Come on, let's go. What are some ways you can compare the distance ran during a marathon and the time it takes to run that marathon? What are some representations do you think would be the most helpful in comparing the distance ran and the time, and explain your reasoning? Well, these are some of the things we're going to be learning about in this lesson. Relationships between two variables can be described using multiple representations. We've been talking about this all module long, such as words, equations, tables, and graphs. By generating multiple representations of the same relationship, you can identify correspondences between the representations. Each representation describes the same relationship in a different way. For example, with words, words help you to express the relationship in using real-life elements. A sucker ran 26.2 miles in 2 hours, 4 minutes, and some seconds. I mean, that's pretty dang impressive. Equations can be used to readily find other values for the relationship that are not already known. And then a table could help you to organize the individual pairs of input and output values. And then finally the graph is going to show you trends in the relationship and can also be used to make prediction. Each one of these has a place. Each one of these are useful for their own thing. So let's take a look at different ways that we could use these four things to represent data. For example, in words, it says on a trip, a cyclist traveled at a constant speed of 14 miles per hour for several hours. You could represent that as an equation saying that the distance d is equal to 14 times the time t. With a table, we could represent it saying that 1 hour took him 14 miles, 2 hours, 28 miles, 3 hours, 42 miles, and so on. And then on a graph, well, the graph is going to end up looking just like that, a great visual representation of the data that we're looking at here. 4 different ways we can show the same information. Example 1 says that the student council has already earned $150 this year. For the next fundraiser, they are holding a car wash and charging $7 for every car that they wash. Represent the relationship between the number of cars washed, C, and the total earned, T, with an equation, a table, and a graph. So they want it 3 different ways. So first thing we're going to do is use the information in the given problem, move through the slides, determine what the independent and the dependent variables are. In the relationship, the number of cars washed, C, that's going to be your independent variable, and leading you to the total earned, which is going to be the dependent variable. So that answers the first part. Next, before the car wash, the student council already had how much money? I believe that was $150. And that $150 is where you're going to be starting from. That means you have a plus $150 on the end of the equation. For washing the cars, they will earn how much per car? I think it was 7, but let's go down here and look. They started at $150, 7 per car. Yep, so it can be $7 for every car that they wash. There's your next piece of information. And from there, we get to take and work on putting that as an expression to determine the total earned. You multiply the number of cars washed by 7, and then you add 150. Your final equation is going to be T is equal to 7 times C plus 150. That's just the first step, though. All we've done so far is write our information as an equation. Now we need to take and represent it, I believe it was, as a graph and as a table. So to represent it on a table, we're going to start off by taking and plugging in our values for C. So if C was equal to 1, that would mean that T, that's not a very nice T, is it? Let's try that again. That T is going to equal to 7 times 1 plus 150, which means it's going to equal to 157. For the next one, it would be T is equal to 7 times 2 plus 150. Well, that's going to be 2 times 7 is 14 plus 150. That's going to be 164. And then we're going to have T is equal to 7 times 3 plus 150. That should be a 50. That's going to give us 171. T is equal to 7 times 4 plus 150. That would equal to 178. And the last one, T is equal to 7 times 5 plus 150, and that is going to give us 180. So let's jump back over and plug in our values here. We've got a 157, a 164, a what was the next one? 71, 78, and 80. 171, 178, and 180. And now we have completed, oops, what I missed there? That's not 180. No, it is not either. That'd be 185 actually is what I should put there. 185. And now everything checks and we've completed the table. With the table done, what's the next thing that we get to work on? Well, we get to work on the graph, I do believe. Now remember, in working on the graph, you have to have ordered pairs. So we're going to convert the table information into ordered pairs. That's 1 and 157, 2 and 164, 3 and 171, 4 and 178, and 5 and 185. Check that. That's checked. And from here we get to take and create all that information onto a graph, I do believe. There's our ordered pairs, and there's a place for us to graph it. Excellent. And now we get to graph it. So our first point is going to be at 157. So I'm going to take my point. I've got where x is 1, y is 100, and right there, 57. Our next point is 164. So I'm going to take and go where x is 2, y is 164, which is going to be right there. Our next point is 171. So where x is 3, y is 171. And then, I think I missed one there. Let's try that again. There we go. And then where x is 4, y is 178. So I'm at 178. And finally 5, 185. So at 5, we're at 185. From there, all we have to do is connect them with a line. And once again, we're using a dotted line here because there's no half measures in what we have. You can either buy the whole thing or not at all. And we can check it. And it says it's incorrect, but it is quite correct. It's probably just that graph right there is a little bit off. So maybe if I run it a little bit closer there, try it again. Yeah, it's pretty close. So anyhow, that's literally all there is to doing these problems. There's a lot of work for them, yes, but the work is totally doable, and it's just the same basic thing we've been doing for this entire module. Now we're on to the final question of this lesson, which is going to be extra example 1. Really, yeah, that's it. We only have one example and one extra example for it, but it's a lot of subparts in this question. So first thing you need to do is read the problem, represent it with an equation. Once you get that checked, then you're going to fill out your table. Once you fill out your table, probably wouldn't hurt to take and do some ordered pairs somewhere, and then you can plot your ordered pairs here, check all your work, see how it comes out. A bald eagle flies at an average speed of 131 miles per hour. Represent the relationship between the hours the bald eagle flies, and they want that to be listed as an H, so let's take and highlight right there, we got as H, and the total distance flown, D, with an equation, and graph the equation. A table and a graph. So for here, first thing we need to do is figure out what our input and our output is. This one right here, that's going to be our input, the total number of hours. The total distance, that's going to be our output. So our equation should be D is equal to how many miles per hour? 31 times some number of hours, H. So I'm going to jump back over to the problem, and I'm going to say D is equal to 31H, and we're going to check that. That part checks. Next, we need to take and fill on our table here. So I'm going to take my screenshot. Alright, so now we're going to take and plug in the values for H into our formula here. We have, whoops, get my pencil back. D is equal to 31 times 1, which is 31. D is equal to 31 times 2, which is 62, and D is equal to 31 times 3, which is going to be 93. From here I can jump back over to our textbook page, 31, 62, 93. Check those answers. Oh, I typed in the wrong thing, didn't I? Try that again, 31. And now all that's left is to graph it. But to do a graph, we have to find the ordered pairs first. So I'm jumping back over here. I'm going to acknowledge that my ordered pairs are going to be 1 and 31 for the first row. The second row is going to be 2 and 62. And the third row, that's going to become 3 and 93. So these are the ordered pairs that I need to graph. To do that, I'm going to jump back over here. I'm going to get a dot, and I'm going to place it at point 1, 31. Another dot at point 2, 62. And our last dot at point 3, 63. Or it can be 93. We're going to connect these with a solid line because you can fly for half minutes and things of that nature. So there's our graph, and check it, and it all checks perfectly. Now that's all we're going to do for this lesson, but I do need to point out to you that is what my supporting work looked like. I can't just throw down a graph, an equation, and a table without having the information to fill it in. You've got to give me all the supporting work if you want credit for tonight's homework. Get started on it. I will see you in class tomorrow.